Welcome back to the lab. Our buddy Ray Maxwell is here. He's an old-timer, been around a long time, and I am an old-timer too, so it's always fun when you come in and you bring your old stuff.
Yes, it's kind of good to look back occasionally when we get all this really super stuff and look where it all came from.
Right.
Yeah.
I think that's actually one of the things that I like to add, and I think that I bring to the table, is that there are a lot of young kids doing technology coverage, but we remember the original stuff back in the 70s when this microcomputer revolution first began.
Exactly.
And it's really valuable to have seen all of this develop, because then you can look at something and say, well, we tried that once before. We've been there. Yeah. And of course, sometimes old timers like us go, oh, you young kids, you'll never understand, and they come up with something pretty cool. So it goes both ways. Yeah. This is where it all began, though.
Yes.
The vacuum tube. Tell us a little bit about this.
When I was in university, I studied vacuum tubes.
Right.
And I was introduced to transistors, and integrated circuits didn't exist. So that gives you the time context of this.
Right.
But these tubes are actually out of ham gear that I used as an amateur radio operator back when I was a teenager in high school.
Well, this goes way back to Lita Forrest and the Audion tube, where he figured out that somehow he didn't understand how it worked, as it turned out. You could create some oscillation that would transmit radio waves.
Right. He finally figured out that a vacuum tube could be used as an amplifier.
Right.
So if we look at this schematic, I'll go through what's inside the tube and how it works. First of all, we had a filament inside here, and this was just like a filament in a light bulb.
Right.
It lit up and it glowed red, and it turned out that we found out it emitted electrons. And if we placed a positive voltage on what was called the plate,
right,
it would pass current through this vacuum. But if we reversed it and made the plate negative, no current would flow. So the first thing that was invented was a diode.
It was a switch.
Yes. It would only let current flow one way, so we could convert AC into DC.
It's actually really a valve, wasn't it? Yeah, a one-way circuit.
And just for Kate, if we were in Great Britain, these would be called vacuum valves.
That's what they call them,
not
valves.
Tubes. Yes.
Because really at first they were valves.
That's right.
Yeah.
So then DeForest came along and put in a grid, which is just a little fine piece of metal between the cathode and filament and the plate. And he found out that if you put a very small negative voltage on the grid, it would cut off the current flow to the plate. So what he found out was that if you could put a very small voltage in on the grid, and if you measured the plate voltage with a resistor in series with it, you would suddenly get a big amplification and get a big voltage out of the plate circuit.
It jumped.
Yes.
In power.
In power.
Interesting.
Now, the interesting thing was the tube was a high impedance device, so you could hook a microphone or a very something that put out a very low signal into the grid circuit, and you could get something that would drive a speaker out of the outside.
So the first use of this would be as an amplifier.
As an amplifier,
speaker.
yes.
And then, of course, E.A. Howard came along and figured out if you did a regenerative circuit where you did it again and again and again, you could get so much power out of this, you could turn it into a transmitter.
Right, a transmitter or oscillator.
And broadcast.
Yes.
Yeah. What an amazing thing. Now, what were these tubes particularly used for?
That was the final output tube in my Viking 1 transmitter that I used as an amateur radio operator, and it would switch from 10 to 80 meters, and I used to talk all over the world with that Viking 1 transmitter. I would talk to places like New Zealand from Missouri.
So this was a regenerative circuit then?
Well, this was just the final output amplifier. I actually started with crystal oscillators to control the frequency.
And you build it up and up and up and up and up.
Right, and then you had a modulator tube in there to put the AM, and it was AM modulation. Then later I went to single sideband.
Isn't that cool? Now what's this other tube here?
That's, again, it's just a higher powered 4-125A.
So it's another transmitting tube.
Yes, it's another transmitting tube.
Isn't that cool? And I remember when I worked in radio, we'd have big tubes.
Yes, we had
in those 50,000 watt transmitters.
Yeah.
In fact, I used to sit across from one and always wonder, am I ever going to have children? It's not, the thing glows,
Did you work with some that were water cooled?
Probably, yeah. It was a big plant. Yeah, they had a lot, because those things get very hot.
Right.
And they've got to send out 50,000 watts of power up that transmitter, that pole, that antenna. Wow, that's remarkable.
Right.
Now, everything changed, of course.
Yes, along came the transistor, and it was a big change for the engineers of the day because transistors are very different. Just to go back a moment, the tube used a small voltage to control the current through the tube.
Right.
A transistor is a low impedance device, and you put a small current. Now I'm going to point again to my diagram.
So this is a transistor on the right.
Transistor on the right, and if I put a small current into the base to the emitter, it causes a large current in the collector. Okay, so it's a current-driven device, and everybody had to rethink how they were going to couple high-impedance devices like microphones and stuff into this. And
so you really rejigger your whole circuitry. You can't just replace a tube with a transmitter. You have to rethink how it works.
Right, you have to think how it works. Took some different designs. Mm-hmm. Now later they came along with field effect transistors, mm-hmm. and field effect transistors are high-impedance devices, and they're much more like tubes.
Interesting.
But that came along way after the original.
Is this a transistor?
That's a power transistor in a TO3.
Look how much smaller. And then this is just the beginning of the miniaturization curve. I mean, this is a single transistor in here, right?
And of course, in every computer now, we have millions of. That's a single transistor. We have millions on one
chip, the same size.
Yeah.
So you've got a factor of 1,000,000 to 1, or more like 5 or 10 million to 1 reduction in size, and that's what's really powered the entire digital technology industry. Is this miniaturization?
Right. Now, I'm going to touch on a controversial topic along these lines.
Oh, I know where you're going here. You're talking about audio.
Yes.
Yeah.
Yes.
Many audiophiles believe that tubes produce a better sound than transistors.
And under certain circumstances, they do. But let me tell you what the circumstances are.
Okay.
In tube circuitry, this is going back again to how you design with tubes versus transistors. When you overdrive a tube, it puts out certain kinds of harmonic distortion. Mm-hmm. And it turns out that the harmonic distortion produced by tubes, due to the nature of the design of the circuit, is more pleasant to the human ear.
So when this distorts, which you shouldn't do anyway,
right,
it sounds better than when this distorts.
That's correct.
But that's the only difference?
Yeah.
If you're driving it at a normal volume, it's fine.
It's just
either
fine.
way, they sound the same.
Both devices in a properly designed circuit.
That's the key, though.
Okay, and if levels are kept at the proper levels, work just fine and are very accurate.
There's more slop in this, in other words, in a vacuum.
And the distortion that happens is more pleasant to the ear.
Well, that's why sometimes rock and rollers prefer tube amps, because when they overdrive them, they sound cool.
I've put a website up in the show notes where a guy goes in. If you want to know the details and really understand this discussion, he does a very good job of explaining it and the harmonic distortion and what happens.
Well, I'm going to build, if I build a time machine, I'm going to build it with these because they look cool, and that's the key. Ray Maxwell's Time Machine. I hope you'll come back with more great stuff from the basement of Ray's house. We do want to encourage you to go to his website, maxwellmultimedia.com, because there's lots of great pictures and more there. He's a wonderful photographer. Thank you so much, Ray. Boy, it's fun to see these. Look at that. The foundation of everything that we're talking about today. Now it's time, speaking of great pictures, to take a look at one of Sean Carruthers' super-duper close-ups. This is our What the Tech contest. This is a close-up of something you commonly find around the lab, but whatever could it be? Looks like a decal on a rain-soaked window, but I'm sure it's not. We'll find out when we zoom out right after these messages. Stay right here.